This video is on the solutions, which is a part of the class 12th of the chemistry. So first of all, we should know what is a solution. A solution, you should remember, it a homogeneous mixture of two or more substances. It is a homogeneous mixture of two or more substances. Usually, a solution is formed between a solid and a liquid. If the solution is formed between a solid and liquid, then the solid is usually the solute and the liquid will be the solvent. Solid is the solute and the solvent will be liquid. However, in case the solution is formed between two liquids, if the solution is between two liquids, then the liquid in less quantity will be taken as the solute, and the liquid in more quantity will be taken as the solvent. So solutions are of two types. One is known as dilute solution, other is known as concentrated solution. If the amount of solvent is quite high as compared to if the concentration of or if the quantity of solvent is quite high as compared to the solute, and that is known as a dilute solution. And if the quantity of solute is more, then that will be known as the concentrated solution. If the concentration of the solute is more. Now we have said that the solution will be concentrated when the solute is more. But how much more or how much less? If you want to express it, then there is a term for that is known as the concentration. So what do we mean by concentration? By concentration we mean how much solute, because we want to express it in terms of a quantity. So how much quantity of a solute has been dissolved in a fixed quantity of solvent, that is known as the concentration. How much quantity of solute has been dissolved in a fixed quantity of solvent, that will be known as the concentration. So there are various methods to express concentration of a solution. We will discuss the main methods which are useful for us. So I think it's clear that concentration means how much quantity of the solute has been dissolved in a fixed quantity of the solvent. And in my video, I'm going to take A as the solvent and B as the solute. I'm going to follow this pattern: A as the solvent, B as the solute. So now the first method by which we can express the concentration is molarity. And molarity is denoted by capital M. Now molarity is defined as the number of moles of solute. The number of moles of solute dissolved per liter of solution. That is known as molarity. How much moles of the solute have it dissolved in the 1 liter of the solution? That is known as molarity. So I can write molarity is equal to how much? Number of moles of solute divided by the number of liters of solution. Now, how will you calculate the number of moles? The number of moles, if I am denoting, say, because I am denoting the solute by B, and if small n denotes the number of moles. And so I can write, since I am using B for solute, so that will number of moles will become NB. And the volume of the solution in liters. So V is standing for the volume of the solution. Now we know that the formula for the number of moles is always given mass upon molecular mass. The number of moles is given mass upon molecular mass. And I'm going to represent the mass by small w or W. Now, since I am taking the solute as how much? B. So I will write the given mass as WB. How much is the molecular mass? MB. So I can say the number of moles of the solute will be WB upon MB. Therefore, the formula for molarity will become WB divided by MB into V. And V is in liters, remember. So that is the formula. And in case the volume is given to us in milliliter and we have to convert it into a liter, we will have to divide it by 1000. So the formula for molarity will become equal to WB upon MB into 1000 by B. So always remember, since molarity is containing volume in the denominator. So the molarity is going to depend on temperature. Remember, molarity depends on temperature. So the second term which is used to express the concentration and which will be often used in this lesson is molality. Molality is denoted by small m. Molality means the number of moles of solute dissolved in 1 kg of the solvent. So by molality we mean the number of moles of solute dissolved in 1 kg of solvent. While in the previous case in molarity that was volume in liter. So molality will become equal to how much? Number of moles of solute divided by the mass of solvent in kg. Now the need for this particular expression for concentration came because the molarity depends upon temperature. However, the molality is containing the mass of the solvent in denominator, which is temperature independent. So molality is not going to depend upon temperature. So for the number of moles, we are going to use the same formula, WB upon MB, but here it will be the mass of solvent. And if I am say denoting, since I am denoting the solvent by A, so my mass of solvent will become MA. So I will have the formula MA, since mass is in kg and if it is given to us in gram, I can write is 1000 upon W. So this is the formula for molality. Say I'm denoting this equation for molarity by M, molarity by 2. And do remember that molality does not change with temperature. Molality is independent of temperature. Now the third uh, expression to express the concentration is mole fraction. This is also to be commonly used in this lesson. Mole fraction means the ratio of the number of moles of a particular component to the total number of the moles. Now, in case we are forming a binary solution means a solution which is obtained by mixing two substances. Suppose I am mixing two substances A and B to form a solution. I have taken, say, the mass of A is how much? WA. The mass of B is how much? WB. Say Ma is denoting the molecular mass of A. Ma is denoting the molecular mass of A. Mb is denoting the molecular mass of B. So if I want to find the number of moles of A, since I know number of moles is the given mass, in fact this is the given mass. This is the given mass of B. So number of moles of A will become how much? WA upon MA. Similarly, the number of moles of B will become how much? WB upon MB. Now mole fraction is denoted by this sign Xe. So it will be equal to how much? Number of moles of A upon number of moles of A plus number of moles of B. And since we know what is Na, Na is Wa upon Ma. Similarly, Na I can write as Wa upon Ma. Similarly, this can be written as Wb upon Ma. So this is the formula for the mole fraction of A. In case I want to write the formula for the mole fraction of B, that will become Nb upon Na plus Nb. So that will become how much? Wb upon Mb divided by Wa upon Me plus Wb upon Mb. So this is the formula for the mole fraction of A. This is the mole fraction for the number of moles of B. Now if I add the two, if I add this and this, so what will be Xa plus Xb? That will be equal to Na upon Na plus Nb plus Nb divided by Na plus Nb. If I take the LCM, I am going to get Na plus Nb. That will be in the numerator, I will get Na plus Nb. This will cancel, it is 1. So I can say that the mole fraction of the A component plus the mole fraction of the component B is how much? 1. So whenever two components A and B are mixed to form a solution, remember the sum of the mole fraction will always be equal to 1. In case I am mixing, in case I have three components A, B, C, even then also the sum of the mole fraction of A plus B plus C will become 1. In case a MCQ comes and we are given that the mole fraction of A is 4 by 5 and we have to find the mole fraction of B. So I can say XA plus XB is how much? 1. So XB will become equal to 1 minus XA. So that will become 1 minus 4 by 5, that is 1 by 5. So this was about the mole fraction. Now the last term which I am going to explain is the normality. Normality is denoted by capital M. And normality means the number of gram equivalents. Normality का मतलब होता है number of gram equivalents of the solute divided by the volume of solution in liters. And how will we calculate the number of equivalents? The number of equivalents can be calculated by the given mass divided by the equivalent weight. Given mass again I am going to take as Wb because I am denoting the solute by B. Equivalent weight say I am denoting by Eb into the volume of solution in liter. Now how will you calculate the equivalent weight? To calculate the equivalent weight, we have the formula. Equivalent weight is molecular weight upon acidity or basicity. In case we have an acid, that will be having basicity. If there is a base, that will have the acidity. So these are the four methods to express the concentration. Although there are more methods, but for us these four are important. So I go on to the next topic now. That is vapor pressure. What do we mean by vapor pressure? Vapor pressure means the pressure exerted by the vapors of any substance. Now, a substance is going to form vapors only when it is a volatile substance. Suppose I have two substances, A and B. I am making a solution from these two solutions. From these two components, both of them are forming the vapors. So, in case Pa naught denotes the vapor pressure of pure A, means when the A component is pure, it is having a vapor pressure of how much? A. Similarly, if Pb naught denotes the vapor pressure of pure B. Now what I have done, I have mixed these two substances and I have formed a solution. Now, if both of these components are volatile, what will happen? Suppose I have a container in which there is A as well as B. Now I am heating it. So when I am heating it, what is happening? Vapors of A will be formed as well as B will be formed. Now since both are volatile, so what will happen? Now if there are the vapors are formed. Now there will be certain pressure due to A. There will be certain pressure due to B. So the total vapor pressure of the solution, if P denotes the vapor pressure of the solution, that will be equal to how much? PA plus PB. Now what is PA? The PA can be written as PA naught into XA. And this PB can be written as PB naught into XB. This is from the Rawls law. This follows from the Rawls law. According to Rawls law, the vapor pressure, Rawls law states that the vapor pressure of a component, the vapor pressure of a component in a solution is the product of its vapor pressure if it were pure. If it was pure, multiplied by the moles fraction of that component. So, according to Rawls law, the vapor pressure of a component in a solution will be the product of its vapor pressure if it was pure multiplied by the mole fraction of that component. That is why I have taken PA as equal to how much? PA naught into XA. PA naught is the vapor pressure of the pure A, X is its mole fraction. Similarly, PB naught is the vapor pressure of the pure B, and XB is its mole fraction. So since both the components were volatile, this is the case when both the components are volatile. So when both the components are volatile, then both the components are going to have a contribution in the total vapor pressure of the solution. So P will become equal to how much? PA naught into XA plus PB naught into XB. Now in case I am mixing two substances. In case I am mixing two substances A and B. A I have taken say solvent that is volatile, and I have taken B as solute. Say it is non-volatile. It can also be that B is also a solvent, but that is non-volatile. Now what will happen since only A is volatile, B is not volatile. So that means in the solution formed only there will be the vapors of A. There will be no vapors of B. So if I write the Rawls law, the total vapor pressure P will be equal to how much? We know that P is equal to PA naught into XA plus PB naught into XB. Now, because our B is non-volatile, so there will be no contribution of this B component in the vapor pressure of the solution. So what will happen? We will be left with only this component. PA is equal to PA naught into XA. And now since AB is having no contribution in the total vapor pressure. So in fact, this is the vapor pressure of A only. So I can write it as PA. Now we know that the sum of the mole fraction of the components of a solution is how much? 1. So XA plus XB is 1. So I can write XA is equal to how much? 1 minus XB. Now I can substitute this value of XA here. So I will get how much? PA naught into 1 minus XB will be equal to how much? P. And remember, I am going to take A as the solvent and B as the solute. So I can say this will be PA naught minus PA naught into XB is equal to P. So from here, I can say if I take this to this side and bring this to this side, I will have PA naught minus PA is equal to PA naught into XP. So from here I can say that PA naught minus PA divided by PA naught is equal to how much? XP. In fact, this equation is known as the Rawls law of relative lowering of vapor pressure. See if I am denoting this equation by which? So what is that PA? PA naught is the vapor pressure of pure solvent. PA is the vapor pressure. VP is indicating the vapor pressure. PA is the vapor pressure of the solvent in the solution. Now, what is PA naught minus PA? PA naught minus PA means lowering of vapor pressure. PA minus PA, PA naught minus P is known as the lowering of vapor pressure. And when we divide it by PA naught, the quantity which we are going to get, that is known as the relative lowering of vapor pressure. This is known as the relative lowering of vapor pressure. So I can say that this is the relative loading of vapor pressure and this is the mole fraction of the solute. So I can say that the relative lowering of vapor pressure, relative lowering of vapor pressure is always equal to the mole fraction of solute, is always equal to mole fraction of solute. So PA naught minus PA upon PA naught, that is equal to how much? Mole fraction of the solute. And what is mole fraction of the solute? Number of moles of solute upon number of moles of solute plus solvent. So this is the formula we have got. Now, in case the solution is dilute, then what will happen? Our solution is dilute, that means the number of moles of solvent will be very large than solute. So I can say PA naught minus PA divided by PA naught is how much? NB upon NE. And NB can be written as how much? WB upon MB. And NA can be written as WA upon MA. So we can apply this formula in the numericals. And the numerical on it is very important. Now, whenever we form a solution, it is observed that solutions are of two types. The first solution is known as the ideal solution, and the second solution is known as a non-ideal solution. So there are two types of solution. One is known as ideal solution, and the other is known as a non-ideal solution. Now, what are ideal solutions? Ideal solutions are those solutions, remember, they satisfy three conditions. Ideal solutions are those solutions, first of all, which obey the Rawls law. So the first condition for ideal solution is that they obey Rawls law. The second condition is that the delta H mixing is zero. What the delta H mixing equal to zero mean? And the third condition is delta V mixing is zero. The first condition is easy, that they obey Rawls law. That means the vapor pressure of a component. Suppose I am mixing A and B are two substances and they are forming an ideal solution. That means the vapor pressure of pure A will be equal to PA naught into XA. Similarly, PB can be done as equal to how much? PB naught into XP. And the total pressure will be the sum of the two. So, ideal solutions are those which obey Rawls law. Now, the second point, for them, delta H mixing is zero. So, when we are mixing the two components A and B to form a solution, so they are going to form a solution. if the total heat of the solution which is formed by mixing A and B is the same as the heat of its component, then there will be no change in the heat content. So that is known as the ideal solution. And third condition which they are satisfying is that there is no change in the volume. That means if the component A is having a volume say V1, component B is having a volume V2, and then the total volume is it is V1 plus V2, then V1 plus V2 will be the same as V1 plus V2, which was the volume of the initial components. So ideal solutions are those solutions which satisfy these conditions. And ideal solutions are generally formed between compounds of same type. Between compounds of same type. What do I mean by this? Suppose I have normal hexane and normal heptane. Both of them you know are alkanes. They are having mass is also approximately same. Similarly, say chlorobenzene and bromobenzene. Again, both of them are aromatic compounds. So ideal solution is formed generally between components of same type. Now, if these substances do not obey Rawls law, then those are known as the non-ideal solution. So what are non-ideal solutions? Non-ideal solutions are those solutions which do not obey Rawls law. And in addition to that, for them, delta H mixing will not be equal to zero. Similarly, delta H mixing will also be not equal to zero. So first of all, I am telling you that what are non-ideal solutions? Those which do not obey Rawls law. Now, since they are not obeying Rawls law, and second condition is that delta H mixing for them is not equal to zero. Means when we are mixing the two components A and B to form a solution, then the total heat of the component A and B is not the same as the heat of A separately and B separately. Similarly, on mixing them, the change in volume is also not equal to zero. That means either there is an increase in volume or decrease in volume. Now, since we can have two cases when they are not equal, that means that can be greater than equal or that can be less than. So we can have two types of non-ideal solution. First of all, which show the positive deviation from Rawls. And the second one, which show the negative deviation from Rawls. So those which show the positive deviation from Rawls law, in those cases, delta H mixing will be greater than zero. Delta V mixing will also be greater than zero. And in those in which there is a negative deviation, delta H mixing will be zero. Similarly, delta V mixing will be less than zero. So before discussing this, if in case we are plotting a graph between vapor pressure, in case we plot a graph between vapor pressure and mole fraction, first of all, we are seeing the graph for an ideal solution. So suppose I have this is my diagram, this is my graph. On the y-axis, I have taken vapor pressure. On the y-axis, I have taken vapor pressure. On the x-axis, I have taken the mole fraction. This is important again from the examination point of view. Now, suppose at this point, what is happening? The mole fraction of A is how much? 0. The mole fraction of B is how much? 1. At this point, the mole fraction of A is how much? 1. Mole fraction of B is how much? 0. Now, since at this point, the mole fraction of A is 0. So what does it mean? At this particular point, there will be no contribution of A towards the pressure. क्योंकि उसका mole fraction is 0. As the mole fraction of A is increasing, its contribution towards the vapor pressure will increase. At this point, what is happening? The mole fraction of A has become 1. It is maximum because we know the mole fraction can be maximum 1. So this graph is going to denote the pressure of A, that is PA naught into XA. At this point, what was the mole fraction? 0. So that is why at this point, the pressure of A was 0. Now here the mole fraction of A is how much? 1. So the vapor pressure of S is also maximum. Now at this point, what is happening? The mole fraction of B is 1. So the vapor pressure of B will be maximum here. Now what is happening? The mole fraction of B is decreasing. At this point, what has happened? The mole fraction of B has become 0. So this is representing the PB. So that is how much PB naught into XB. Now if I join this line to this line, this is going to give the total vapor pressure. So that is how much PA plus PB. So for an ideal solution, the graph is going to be like this. For the vapor pressure versus mole fraction. Now one thing before I go ahead, see vapor pressure. It is always observed that the vapor pressure of the pure solvent will be more if we add a solute to it. Whenever we add a certain solute to a solvent, when we add a solute to a solvent, what happens is vapor pressure always decreases. Do remember, vapor pressure decreases. That is why while discussing the Rawls law of relative loading of vapor pressure, we saw that if PA was the vapor pressure of pure air, and if PA is denoting the vapor pressure of A in solution. So what we will observe whenever we are going to add certain solute to a solvent, always remember there will be a lowering in vapor pressure. There will be a lowering in vapor pressure. That is why due to the lowering in vapor pressure only, we have to heat a liquid more so that the vapor pressure will become equal to the atmospheric pressure. Because we know a liquid boils only when the vapor pressure becomes equal to the atmospheric pressure. When we add solute to any solvent, vapor pressure decreases. Now to go back to the same situation, to the original vapor pressure, we'll have to heat the liquid. Now I told you that non-ideal solutions are of two types. First, positive deviation from Law's law. Second, negative deviation from Law's law. So when is a solution is going to be formed, which will show deviation, positive deviation. When is a solution will be formed, which will show a negative deviation. And before going that, let us see the graph for the positive deviation from Law's law. In case a solution is formed, which is showing the positive deviation from Rawls law. In case we have a solution which is showing positive deviation from Rawls law, we are plotting a graph between the vapor pressure and mole fraction. Here x is how much? 0 say. Xb is how much? 1. Here xa is how much? 1. Xb is equal to how much? 0. Now, if it were an ideal solution, it would have been like this one graph. Now, since it is showing a positive deviation, so the graph will go in the upward direction. This is the graph for A. That is PA is equal to how much? PA naught into XA. This is the graph for B. PB is equal to how much? PB naught into XB. This is the graph for total. Now, since it is showing more vapor pressure than expected, it is showing more vapor pressure than the expected. In case there is a negative deviation, from Rawls law. Then the graph between vapor pressure and the mole fraction. So in case on the y-axis I am having vapor pressure. Here I am having the mole fraction. Suppose here x is 0, xb is how much? 1. Here x is how much? 1, xb is 0. So in case it were an ideal solution, would have been like a graph like this. Now since it is showing a negative deviation, graph goes down. This is the graph of PA naught into XA. This is the graph of B, PB is equal to PB naught into XB. The last topic in this is when is the substance going to show positive deviation, and when is the substance going to show negative deviation? Positive deviation. So suppose I am mixing A and B. I am mixing two substances A and B to form a solution, and the forces between them were previously stronger. ए और बी के बीच में जो इंटरमोलिकुलर फोर्सेस है, क्योंकि आई एम मिक्सिंग ए एंड बी टू फॉर्म अ सॉल्यूशन, so there will be some molecules of A, similarly there will be some molecules of B. Now if the forces between A and BB are greater, now when I'm mixing A and B to form a solution, अभी क्या A I am mixing A and BB to form a solution, जो A और B के बीच में फोर्सेस हैं या जो BB के बीच में फोर्सेस हैं, in case they are stronger, and when I am mixing them to form a solution AB, now what will happen? There will be forces between A and B. There will be forces between A and B. Now when the forces between the molecules A and B are weaker as compared to the forces between A and AA or BB. So what will happen? Now the forces have become weaker. Now if we heat the liquid, what will happen? Its vapor will be formed easily. और जब उसके वेपर इजीली बन जाएंगे, जब उसके क्या हो जाएंगे, वेपर प्रेशर इजीली बन जाएंगे, तो व्हाट विल हैपन, इसका मतलब उसका वेपर प्रेशर क्या हो गया, इंक्रीज हो गया. फॉर एग्जांपल, इसका एग्जांपल जैसे कार्बन डाइसल्फाइड है CH2 एंड एसीटोन. Now the forces between the molecules of carbon disulfide when they were existing in the pure state, they are more. Similarly, the forces between the acetone, they are stronger. Now when we are mixing them, what happens, जो इनके बीच में फोर्सेज हैं वो कमजोर हो गए. अब जब ए और बी के बीच में जो फोर्सेज ऑफ अट्रैक्शन वो वीक हो गए, तो अब वो मॉलिक्यूल्स आसानी से वेपर बना लेंगे. तो जब वो वेपर आसानी से बना ले रहे हैं, इसका मतलब क्या हो गया, वो सब्सटेंस वेपर में जल्दी कन्वर्ट हो जा रहा है. तो क्या हो गया, वेपर प्रेशर उसका इंक्रीज हो गया. अब निगेटिव डेविएशन कौन शो करता है? निगेटिव डेविएशन वो शो करते हैं रॉल्स लॉ से वो सॉल्यूशन जिनमें क्या होता है, पहले ए के बीच में जो फोर्सेस आ रहे हैं वो वीकर है, इसी तरह से बी के बीच में जो फोर्सेस हैं दे आर आल्सो वीकर. अब जब हमने इनको मिक्स करके ए बी बनाया सॉल्यूशन, तो व्हाट विल हैपन, नाउ द इंटरमोलिकुलर फोर्सेस आर इंक्रीज्ड, ये बढ़ गए स्ट्रेंथ में, दे हैव इंक्रीज्ड. अब जब ए और बी के बीच में इंटरमोलिकुलर फोर्सेस बढ़ जाएंगे, तो क्या होगा, इसकी वेपर बनाने की टेंडेंसी कम हो जाएगी. और जब वेपर बनाने की टेंडेंसी कम हो गई, इसका मतलब क्या होगा, इसका वेपर प्रेशर अब कम हो गया. तो जो सब्सटेंसेस नेगेटिव डेविएशन शो करेंगे रॉल्स लॉ से, उनका वेपर प्रेशर कम हो जाता है. जैसे इसका एग्जांपल है एसीटोन. और क्लोरोफॉर्म। तो एसीटोन और क्लोरोफॉर्म के मॉलिक्यूल्स के बीच में फोर्स ऑफ अट्रैक्शन पहले कम होता है, लेकिन व्हेन दे कम इन कांटेक्ट विद ईच अदर दे फॉर्म हाइड्रोजन बॉन्ड, और जब ये हाइड्रोजन बॉन्ड बनाएंगे तो एडिशनल एक और फोर्स ऑफ अट्रैक्शन इनमें डेवलप हो जाएगा। एंड ड्यू टू दिस अट्रैक्शन व्हाट विल हैपन, नाउ दी what will happen, we will have to heat more the liquid to convert it into vapors. So what has happened, the vapor pressure has increased. तो वो substances जो positive deviation show करते हैं उनमें जो A और B के बीच में forces of attraction हो जाते हैं वो weaker हो जाते हैं, और जब वो weaker हो गए तो क्या हो जाएगा, उस substance के vapor आसानी से बन जाएंगे, यानी कि उसका vapor pressure increase हो गया। और जो substances negative deviation show कर रहे हैं उनमें क्या हुआ, A और B के बीच में जो है फोर्स ऑफ अट्रैक्शन अब इंक्रीज हो गया। जब इंक्रीज हो गया तो मॉलिक्यूल्स एक दूसरे को ज्यादा अट्रैक्ट करेंगे, तो क्या हो जाएगा, वेपर प्रेशर अब डिक्रीज हो गया, तो आपको ज्यादा हीट करना पड़ेगा।